the functions here. Now, we know about the functions. Functions are useful when we want to perform a certain task multiple times. So instead of writing the multiple time those codes, we'll put the code inside the function and we'll just call the function instead of that. So in the function, we'll accept the input and it will produce the output, right? And here we have two type of functions available. We have the built-in function, which are the functions which are available in R, as well as we can create a user-defined functions. Just like in other languages, we have built-in function and one type of function is called user-defined functions. So let's see some of the built-in functions here. Now, we have built-in function like view, str, head, tail, table, min, max, mean, range, all those different type of methods are there. Now, all those methods will be inside this list. We can go through that particular list and we can find out the different methods available. So you see, we have different commands, methods, which is somehow listed here. The basic function list are there, and yeah, most of the functions we'll use right now. So let's start with the data set which we have in the R. So in today's class, you will learn a little bit more related to data set and how we'll work on the data set and all. As I told you, the last class will be all about that. Now here and in R, when you install the basic package, so there is iris data set which is available. Now we can view this particular iris data set with the help of view function. This famous Fisher-Anderson's iris dataset gives the measurement of in centimeter of the variables sepal length and width and petal length and width respectively for 50 flowers from each of 3 species of iris. The species are iris. We have setosa. One is versicolor and another is virginica. Okay, so these are the 3 species and different petal length and petal width were there related to it. So let's execute this and try to understand that particular data set. Now here we have different species name of that particular flower. Sepal length and sepal width it's there, and petal length and petal width is there related to the flower. Okay. Now here in this particular data set, we can apply different built-in functions like view. So with the help of view, we can see the data set. With the help of str, we can display the structure of that particular iris data set. Okay. So here you can see it will shows the structure of it. Means that we have 150 observations and 5 variables. It means that we have 150 rows and 5 columns in that particular data set. And the first column, which is a sepal length, is of numeric type, and these are the values. Sepal width is also a numeric type. These are the value. Petal length, numeric type. Then we have petal width is also a numeric type, and species is a factor, right? So we have different 3 levels, right? So 3 levels are there, which is of 3 species name, right? So it is of factor type. So the information which is provided by str, which is short form of structure. Then we can apply the head and tail. So head is one function by which we can see the first six or data of the data set. So it will show you the first six data into the data set. So if you don't want to see whole data, let's say if you have a very big amount of rows available in a particular table. So instead of looking for all, let's look for sample of it. So we can have the head. With the help of head, we can do that. Then there is a tail also, the tail function. So with the help of tail function also we can have. So it will show you last six. So from 150 to 145 value it is printing. Then we have we can see the frequency of any particular column from the data set with the help of table. Now this table will have many things. We'll just put the data set. This is the data set, and inside the data set, which particular column we are looking for. So let's say species. Yes. So we have here like Setosa is 50, versicolor is 50, and Virginica is also 50. So you have 50, 50, and 50 count of all these three, what we can say, the values. Okay. So it will tell you the count of or the frequency of a particular. Okay. Now, after that, we have different arithmetic operations like min, max, mean, range, and all those things. Like if we want to see the minimum of let's say in the arrays, let's talk about the sepal length, the first one. So the minimum sepal length will be 4.3. What is the maximum sepal length here is? So let's get that also. So the maximum is 7.9, right? Then we can apply the mean also. Mean is 5.84 is the mean, the average of all the sepal length of flowers which are given. Then we have the range. Range is also a function. It is ranging from 4.3 to 7.9. So we have seen like minimum and maximum value, right? So minimum is 4.3 and maximum is 7.9. So it is ranging from the minimum value to the maximum value. So in that way, we can also find out with the help of range, we can find out minimum and maximum. We have different other what we can say, the functions are there, inbuilt functions are there, which will work for the numeric data. Let's say we have a numeric data x and we'll put the value like let's say 5.6. So it is of double type and floating value are there. Now we can apply different functions like ceiling, floor, absolute value, SPRT, truncate, and all those things could be applied. So let's see one by one quickly. Let's say we are printing the ceiling value of this. Wait a minute. I need to execute. Yeah, so the ceiling value it is saying for 5.6, it is 6. We can find out the floor also. Floor value of it, it is 5 is the floor value. Then we can find out the absolute value. 5.6 is the absolute value. We can find out the square root of any with the help of SQRT. Let's say we'll put some value there. So we can find out the square root of some value. Let's say we have a vector which is having some values like some floating point values. And let's say I want to have this y without the floating point. So we'll use the truncate. Okay, it will just go and find out the ceiling value of all the value in the vector. Okay, so let's execute these two together. Okay, so it is C 1.5, it is giving me 1, 2.3, it is giving me 2, 5.7, it is giving me 5. Okay, so it is giving me the floor value of all means it whatever the value is after that is going to ignore. So it is giving me 1, 2, and 5 as a output. These are all different type of functions which we can apply into a particular numeric value. Okay, for the data set like we have seen already, the Aries data set. So this is the Aries data set that we have seen. We have seen many functions here. We have some more functions like summary function. It is very much useful function. The summary function will tell you the summary of it. Like let's say the numeric column is sepal length. What is the minimum value? What is a medium value? What is a mean value? What is the maximum value? In that way, the summary is going to give you. With the help of names functions, we can find out the name. Name means all the column available in that particular data set. So it will give you, like we have how many, 1, 2, 3, 4, 5. 5 attributes or 5 columns are there in that particular data set. We can also find out how many number of rows are there with the help of n row, right? So we have 150 rows. How many number of columns are there related to it? I think that thing I have already told you. Number, we can find out the length. Length is 5. Length is the same as your column, the number of column. We can find out the dimension of it, right? Dimension, it is showing 150 into 5 means 150 rows and 5 columns. We have another function called column names, which is same as names. Okay, which is same as names. Head tail we have already seen. So we have different built-in functions available with different which will apply in different objects. So you have to look for object specific built-in functions which will apply in a particular object in R. Okay. Now let's see some of the user defined functions. So we can define the functions. Let's take this example and see how the function has been defined. So let's say we have a function named even odd, and this even odd function has been created by putting one argument x. If x modulo 2 is equal to 0 means the remainder, if it is we are getting 0 means it is even, otherwise it is odd, right? And it is going to print the calling of the functions by once is even, another is odd. So in that way, we are getting the even and odd as a output of that particular function. And this particular function, as you can see, is very easy to understand. So the function method we have to apply, and inside that function method, we have to put all the argument that we want to take. Let's say we want to take another argument here. Then all those argument we have to put it here in that particular place. And the name of the function is this. Okay. So somehow the syntax is different, but more or less whatever a function is doing, it is also doing the same. Now this is also the function, it is taking the radius as an input, and it will calculate the area of any circle. And yeah, so it is also a simple example where it will calculate the area of a circle. Now let's talk about the function with different argument. Here we have seen only one argument. Let's see two arguments. So here we are taking length and width, and inside the function definition, we have calculated the area, then perimeter, and the results. We have made a list where area has been printed and the parameter has been printed, and this result will be written. This whatever the result which is written, which is given to data set here as a list, and this will be printed. So it is printing the area and it is printing the parameter of a particular list. So this is one example where we have seen the usefulness of list, how we are returning the value in the form of object. That object will be given to another variable, and this variable will become the same object, which is a list. And in the list, we can get a particular key value. So here with the area, we are getting the value 6, and with the parameter, we are getting the value 10, if 2 and 3 will be the input. So this is an example of multiple input or multiple argument. Now let's see the inline function. So here we doesn't have a keyword like inline, unlike the C++. So C++ has a inline keyword which we put just before the function name, so that, or the function declaration, so that we can tell the compiler that this particular function will be inline function. Now, what is the significance of inline function? Now, in the normal function, what happen is whenever we make a call of the function, this function will go to the definition of that particular function, and after executing the definition of a function, it will come out and control will come to the place where it has been called. Now this will happen to the normal function call. Now what happened in the inline function call? So inline function is looking like a simple function, but whenever we call the inline function, the definition of the inline function will be copied in the place of where we called it. So the control doesn't have to go to the particular definition of the function execute and again come. So instead of taking time to save the state and going to a different place and then executing again coming back, so that time will be saved using the inline function. So the property of the inline function is it should be like one line function, and it should not be any complicated function. So if it is a simple function like this, where in this particular function we have written in one line, we are taking the value of x, and what it is giving x to the power of 2 into 4 plus x divided by 3. So this is a simple calculation that has been done, and this will be written with whenever we call the function f, right? So f with 4 minus 2 and 0, whenever we call this particular whatever I have selected will be copied here, and x will be replaced with 4. Now here all will be copied and x will be replaced with minus 2. Here all will be copied and x will be replaced with 0. So that will happen when we create the inline function. So remember, inline function is not a command to the compiler or the interpreter. It is just a request to the compiler or interpreter. So if it is not fulfilling the requirement of the inline function, then it will act as a normal function. Yeah. So let's say if we have 2 more lines, so we have to use this, right? And we have to apply like this. Now this will be, and this will not be good. So if we have only one line, so we can put in one line. This is your inline function in R. Now passing the argument into the function, so we can pass the argument like this. Let's say it required 2 argument and has been given some default value here. So as you can see, this is the default argument we have already been provided. So in the first case, we have called the function with 2 values. So whenever we do not give the value to any of the variable, it will take the default value. Otherwise, it will take the value whatever we have given. So here, in the first scenario, we have given 2 and 3. So 2 will go to the length and 3 will go to the width. Now in the second scenario, we have changed the sequence, but we have given the variable name like width equal to 8 and length equal to 4. So 8 will go to a width and length will go to the 4. Now in the next, we haven't given any value, so it will take the default value, whatever it has. Okay, so these are the 3 cases by which we can understood that how this function is going to work with the default argument, right? There is a lazy evaluation of function. So there is a concept called lazy evaluation. Now in this particular concept, what will happen is, see, it required 3 parameter: diameter, length, and radius. Now here we haven't given the 3, we have given only 2. So what it will do is, the 5 will be given to diameter, 10 will be given to length, and radius has not given any value. So it should give the error, but because in the definition, the radius is not at all useful, right? So in that particular case, this will not produce any error. If you'll use the radius somewhere inside the definition of it, it will produce the error. But in this case, where we are not using the radius anywhere in the definition, it will take the value of diameter and the length, and it will execute in a normal way. So it is executing in the normal way without giving any exception. Okay. So that concept is called lazy evaluation. Then the recursive function, we know about the recursive function, the function calling itself, right, inside a function. So here also is the example where there is a recfac, recfac is the function name. So here we are calling it self in the return of it. So at the time of return, it is doing the factorial of it. So it is just the factorial function, and we can call this particular function by giving some value. Yeah, so it is giving the factorial of 5, right? So this is a recursive function in the R. Now let's talk about the file handling into the R, that how we can handle the file. So we have many ways or many functions which will help us to handle a file. So let's say the first is if we want to create any file, so we can create the file with the help of create function. So file dot create function will create a file. Now, if the demo file is already exists, so it will truncate it. Truncated means all the value inside the file should be deleted and it will taken as a fresh one. If the demo.txt is not there, then it will create it. Okay. So with this particular, it will create the demo.txt here in the current directory. So this is the current directory I am working on, as you can see. Now, when I'll execute this, the output is coming as true and this demo has been created, but it is of 0 byte, means nothing is there inside it. Now let's see the iris data set. So iris data set we already have, right? These are the not iris data set. It is the flower species and its specifications are there with the 150 entries. Now what we do is we write some of the rows into that particular iris data set into the demo.txt. So for that we use write.table command and we'll give the first argument as the source and the second argument as the destination. So source is my iris. From the iris, I have taken the first 10 rows and after that all the columns. If I'm not specifying the column, it will take all the columns. So first 10 rows and all the column will be written back into the file demo.txt. So let's execute this. If we'll execute, after that we can see the demo.txt, right? Sorry. We need to open it. So this is your demo.txt. Inside that you can see the first 10 values are there with the sepal length, sepal width, petal length and petal width and the species name. Okay. Now let's go to another function. Let's say we want to rename it. The demo.txt will be renamed to demo new.txt file. So we can rename the file with the help of this command. It is saying true. Now with the help of so demo has been removed and instead demo new has been done. So we have just renamed the name of the file to demo new here. With the help of file.exist, we can see the existence of the file, means file is existing in a particular place or not. So here all the thing is going on into my current directory, the working directory where I am writing the program. So if I'll say file.exist demo.txt, so because demo.txt doesn't exist here, when I'll execute this, it will give me the output as false. And for the next one, whether the file exists for the demo new.txt. So in that way, if we'll execute this, it will give you true. Now, what we do is we just read the file. So how we'll read the file? So we'll have the function read.table, where we'll give the file name as demo.new.txt and we'll put it into the data frame. So we'll create a data frame new.iris here. So we'll execute this. After executing this, let's print that particular data set we have. So this is the data set we have. And you can see all the value has been taken from the demo.txt. So from the demo.txt, 10 value has been, all the 10 value has been read by the dataset and put it into the new.iris dataset. This new.iris you can work with view also, because now it is a dataset. See, the view is going to work here. This is the data set we have in new.iris. With the help of list.file function, we can list out all the file which is available in a particular current directory where you are working on. So let's see this. Here we have all these files are available in this particular. So all the file which is here is listed here.